Hello, my name is Kadekar Vandana. The topic today we are going to present is a sarcasm detection. Sarcasm is a linguistic phenomenon in which people state the opposite of what they actually mean. These are the content which we'll see today. The problem statement. Sarcasm analysis is a technique or a linguistic phenomenon to identify people's opinion, sentiments, attitude and emotions towards any product, event, organization and services. With the increase in the use of the smart mobile devices and with the facility of the high-speed internet, users are able to use the social media sites like Facebook, Twitter, WhatsApp, Instagram, etc. The goal of this project is to identify the sarcasm in a plain text. The project plans to exploit the property of the general sarcastic statement of a possessing contrasting sentiments by using a natural language processing. The project aims to at training a machine learning model to detect if a given statement is a sarcastic or a regular sentence. Aim and objective of our system is first to implement an algorithm for automatic classification of a text into positive and negative to determine whether the attitude of a mass is a positive or a negative towards the subject of interest. Third, to identify whether the statement is a sarcastic or a non-sarcastic. Scope of our system is this project will be helpful to the companies as well as to the common people. Similarly, companies also can get review about their new product on newly released hardware or software. By analyzing the sentences, analyzer can get a result on how positive or negative or neutral are people's about it. Functional requirements. Functional requirements are the functions or features that must be included in any system to satisfy the business needs and be acceptable to the users. First, upload the text file. After the user log in to the system successfully, he or she will be able to upload the input text via the browse option provided on the respective UI. Second, to detect sarcasm, the file which was uploaded by the user will be processed by the system in order to find out the polarity, that is whether the sentence is a sarcastic or a non-sarcastic of the respective sentence. Third, display result. The result will be shown to the user which will consist of the sentences along with its polarity. These are the software and hardware requirements. System architecture. The proposed model is used to select more representative features to classify text into sarcastic or non-sarcastic contents. Firstly, the input given to the system in a text file, then the raw text file is pre-processed using various pre-processing techniques. The pre-processing is a data mining technique which is used to transform raw data in an efficient and useful format. In a preprocessing step, the unwanted data is being removed, that is, the data which does not contribute much to classification process. After preprocessing, the features are extracted and represented using a unigram representation. For a feature selection method, two stages are used. In first stage, conventional feature selection such as chi-square, information gain and mutual information are used to select features. Information gain is used to calculate by comparing the entropy of the data set before and after transformation. Chi-square is used to test whether the occurrences of specific term and occurrences of a specific class are independent. Mutual information calculates mutual dependence of two random variables. In second stage, k-mean clustering algorithm is used to select most representative features from feature set similar information into k number of a cluster. Finally, the feature subset are classified using different classifiers such as support vector machine, random forest, and naive Bayes. Random forest is an automatic learning technique which combines the concept of random subsets and bagging. Naive Bayes classification model computes the posterior probability of a class based on it. It uses the Bayes theorem to predict the probability, and then the output are generated whether the statement is a sarcastic or non-sarcastic in a graphical format, and also text file is generated.
Hello, I am Rupali Modi. This is a use case diagram of our system. In that, there are 7 use cases: manage profile, validate user, upload text file, detect sarcasm, train the system, display result, approve user, and 2 actors, those are user and admin. First use case is a manage profile. In that, the user manage their own profile like login into the system and add update any information about them. Validate user. In the validate user, the admin validate user details. If details are correct, then admin will give the access to the user to access the system. Upload text file. In that, user upload the text file of different sentences. On that file, the sarcasm can be detected. The system will train the data of the system, then the result will be displayed to the user, then admin approve to the user. This is activity diagram for uploading a file. From upload file GUI, the user select browse option, then user browse the file. After that, user submit the text file. Then browse GUI validate the file whether file is in text format or not. If file is in invalid format, then user need to browse a new file. If file is valid, then the file will be stored and generate the result and message display to the user whether is it success or failure. This is an activity diagram for detecting sarcasm. The retrieval file is given to the sarcasm detector to detect sarcastic sentences. In that first the file is processed, then the features are extracted. It builds a valuable information from a raw data. After that the classification algorithms are applied to classify the features. And last, the sarcasm detector generates the result of the text file. Then the result will be stored in the modified file information. This is activity diagram for displaying result. Controller fetch the timestamp, means the date and time of the file. Then this timestamp given to the retrieve file and the file is displayed through display result GUI. This is the class diagram of our system to uploading a file. In that, the three classes are used: uploading file GUI, controller, text file info. In uploading file GUI consists of various attributes such as username, password, file name, file size, timestamp, and upload function is used to upload the text file. After the uploading file, the controller is validate file, whether the file is valid or not. The text file information class store the file. This is the class diagram for detecting sarcasm. In text file info class, the information about the file is available. Then the file information is retrieved using the retrieve file information function and it is given to the sarcasm detector. In that the file is preprocessed using preprocess function. Features are extracted using extract feature function and then sarcasm detected using detect sarcasm function. Then this detected result is given to the modified file info. In this class, the file is stored using store file information function. This is a class diagram for displaying result. The modified file is given to the controller to generate the result and then the result is displayed to the user using display result GUI. This is the sequence diagram for uploading file. The user is logged into the system, then browse the file. After that, the file will be validated. If file is invalid, then failure message will be passed to the user. If file is valid, then the successful message passed to the user and file will be stored. This is the sequence diagram for detecting sarcasm. User will give the file and the file will be preprocessed the data, then extracted the different features, detect the sarcastic sentence, then store the file and then the result will be generated. This is the sequence diagram for displaying result. In that the user is request for result, then the modified file is give the result to the controller and then using display result GUI the result will be displayed to the user. This is the component diagram. In that there are three components: training database, testing database and system server. The system server uses the training database and testing databases to give the information to the user. The data preprocessing can be done in the utility package and user interfaces uses the system server to access the data and the system operation details are used the system server to check the accuracy. This is the deployment diagram in which the user uses the web server to access the data using their private network, like choose the file, check the accuracy of data. Application server is connected to the web server to share the user information and database server is used for storing the file and is connected to the application server so it can be accessed the file.
Okay, so let's start with the snapshot of the system. First one is a training data set. The data set is in a CSV format, that is a comma separated values. First field in it is ID, which is of integer 64 type. Second field is a category, and third field is a actual tweet. This data set contains 5402, that is 5400 rows of data. This data is in raw format, that is it contains misleading informations like symbols and not available text, so we need to clean it before we use it. For training purpose, we have to remove all the misleading data from this data set, that is a number of symbols, not available fields, and number of mentions and links mentioned in the tweets. So basically we need to clean the data set before we can use. So move towards next slide. This is a snapshot when we remove and symbols from the data set. The first field in output shows that the integer 64 type of ID. Second field is an emotion. As it is a training data set, we have assigned a label to the tweet that classifier algorithm can easily understand what type of tweet it is. Then the third field is text, and fourth field is original tweet. Third field is a result of cleanup function, which is called above on this data frame, and as output of this function we can show a text field with no symbol in it. Also we have removed the fields in original tweet that is contains not available, that is no sentence available, no tweet available. That kind of rows we also eliminated from that dataset. After this, we have to build a word list for our training module. For that, we have to count the number of words from the data frame containing training data. We have here counted a number of words in that cleaned data frame, and also removed stop words in that dataset like not, the. These kind of words are removed from the data frame. Then from that words we have built a word list, that is a bag of words. In output, the bag of words is shown. Every word in the word list is attached in a data frame with different columns. The second column is label, that is an emotion, and the next all columns are the words from the bag of words or the word list. This is to find that what type of words are common with which emotion. Moving further, this is an word list file. This word list is also a CSV file which is used to compare the words from training module and testing module. For testing also, we need this word list to compare these words with the word list built with testing dataset. This is a testing dataset. It contains only two fields, ID and category. Category means a tweet, and ID is again integer 64 type of number. Before doing any further operations, we first need to clean it from symbols and unnecessary links and not available fields. Here we are testing random forest classifier for our training module. We have trained this random forest classifier and tested it on a training dataset, and we got the following output. The accuracy of this model is 56%. We need to cross-validate this random forest classifier. After cross-validating random forest classifier, it shows the accuracy 45%. This is the next classifier algorithm and the latest one, which is XGBoost classifier. First, we have to test this XGB classifier on our training module. As you can see, its accuracy is 59% and it is quite greater than random forest classifier. That's why we are using this in our system. This is a result underscore xgb.csv file. It is generated when we successfully got the result from a test dataset. Here in tweets field, the original tweets from the testing dataset, and the category field shows the emotion of its of its tweet. This file is generated when we call an predict method from XGB classifier to a testing dataset, and we got the following accuracies. This is a graphical representation of result.csv file. We have 208 negative tweets in our testing dataset. As we can see in a graph, positive comments or positive tweets is more than neutral and negative tweets.
Hi, my name is Zupali Kote. Further, we are going to see the slides which is containing the literature survey. So the literature survey is being carried out on 4 papers. The first paper is Proposed Approach for Sarcasm Detection in Twitter, which is being published in 2017. So it's consisting of different steps in it. First is data is collected using Twitter Archiver. Second, pre-processing of the data is done, that is the unwanted stuff is being removed which is being not contributing to further processing. Third, polarity of the data is found, that is whether the sentence is being sarcastic or non-sarcastic is being found out. Fourth, data is trained and tested on the Navy bias and the accuracy is calculated using Veka. Second paper is review paper, Sarcasm Detection and Observing User Behavior, which is being published in 2017. So following are the methods for sarcasm detection on Twitter: feature extraction, sentiment related features, punctuation related features, syntactic and the semantic feature, pattern related feature, pattern based approach is being used in this. Again, the classification algorithms used here are SVM, k nearest zero neighbor, and so on. Third paper is on opinion mining in Twitter, how to make use of the sarcasm to enhance sentiment analysis, is being published in the 2015. The Twitter tweets are being used mostly here, as we all are aware that the tweets limitation was just 140 characters, and the use of the informal language, the state of art approach of sentiment analysis present lower performance in the Twitter than that when they are applied on the longer text. Moreover, presence of the sarcasm makes the task even more challenging. Sarcasm is present in the sentence when a user completely states opposite of what he actually wants to convey. This paper proposes a method that makes use of the minimal set of features yet efficiently classify tweets regardless of their topic. Fourth paper is semi-supervised recognition of sarcastic sentences in Twitter and Amazon, which is being published in 2010. So here mostly the two data sets are being used, one of the Amazon and another is of the Twitter. The algorithm used here is a semi-supervised. The input given is a small seed of labeled sentences. The seed is annotated in the discrete range of 1 to 5, where 5 indicates that the sentence is completely sarcastic and 1 indicates that the sentence is non-sarcastic. Here two basic feature types are used, syntactic and the semantic features. The steps performed in this approach are data preprocessing, pattern extraction, pattern selection, pattern matching, punctuation based features, data enrichment, and the classification. So, training and the testing data sets are used. The data set is divided into 5-fold cross validation. That is, each time of 4 part of the seeds are used as training data, and only this part is used for the feature selection and data enrichment. Project plan was accordingly planned. Conclusion: in this work we discuss problem of understanding emotions in the text by machine. So the basic idea of implementing this project was just to implement such a classification algorithm which is going to give us a better accuracy, so that the system will be able to clearly identify whether the sentence is being sarcastic or non-sarcastic. So for this purpose, the classification algorithms which are being used are the support vector machine, that is SVM, random forest, and the XGBoost classifier algorithm. Thank you.